Section 5.6 is on the remainder and factor theorems. The remainder theorem says that given a polynomial function, f of x, when it is divided by the binomial x minus r, the remainder is f of r. So let me show you how to do this. This is actually kind of a cool little trick, okay? So if f of x is 3x cubed minus 6x squared plus x minus 11, find f of 3. Now, we could plug 3 in for x and just kind of PEMDAS the whole thing. But using synthetic division, it's a lot easier. So what I'm going to do is I'm going to divide, oops, that's a little sloppy, divide the polynomial by x minus 3. Now, why a negative 3? It's not really a negative 3 because the form says x minus r. In this case, my r is 3, so I'm going to do x minus 3. So, do you remember synthetic division? We put the 3 in the box out here, and then I grab the coefficients from my polynomial. 3, negative 6, 1, and negative 11. Draw a line down here, and bring down the first coefficient, 3. Now I take the 3 that's in the box, multiply it by the 3 down below, and put that number here. That gives me a 9, and now I add. Negative 6 plus 9 is 3. Do it again. 3 times this 3 is 9. Put the 9 here. Add. That gives me a 10. Remember, draw a line before your last one. 3 times 10 is 30. And then add. That gives me a 19. Remember, 19 is my remainder. Okay, and according to the remainder theorem, whatever the remainder is, that's what f of r is, f of whatever I divided by. So, f of 3 is equal to my remainder, which is 19. Maybe a little extra work, but I think it's a lot easier than plugging 3 in and doing the PEMDAS thing. Let's try another one here. So if f of x is 4x to the 5th plus 2x cubed plus x squared minus 1, find f of negative 1. Now notice I'm missing an x to the 4th and I'm missing an x, so I'm going to have to do some zeros in there. So f of negative 1, so put negative 1 in the box. List your coefficients. 4, 0 for x to the 4th, 2, 1, 0 for x, and a negative 1 at the end. Draw your line, bring down your 4, and start doing synthetic division. Negative 1 times 4 is negative 4. Add those, negative 4. Negative 1 times negative 4 is positive 4. Add those, 6. Negative 1 times 6 is negative 6. Add those, negative 5. Negative 1 times negative 5 is 5. Add those, it gives me a 5. Here comes my remainder. Negative 1 times 5 is negative 5. Add those, negative 6. Remember, the remainder is the number I'm looking for. So f of negative 1 is negative 6. Seems a little tedious, but I think it's actually easier once you kind of get the hang of doing the synthetic division. This is sometimes also called synthetic substitution. Now, the factors theorem says that if a polynomial f of x is divided by x minus r, as we did in the remainder theorem, and in this case, if the remainder is 0, then x minus r is actually a factor of f of x. Okay? So this time, our remainder should end up being 0, and then x minus r is a factor of f of x, and whatever else is left are factors. So let's try this example. Given a polynomial function and one of its factors, find all of the other factors. So I have x to the 4th plus 2x cubed minus 8x minus 16, and I know that one of the factors is x plus 2. So I'm going to do synthetic division on this. Since remember, this is in the form x minus r, okay, so my r is actually going to be a negative 2. That goes in the box. List your coefficients. 1, 2. Notice I don't have an x squared, so I need to put a 0 in there. Negative 8 and negative 16. And let's do synthetic division. Bring down your 1. That's going to give me a negative 2. Add those, it gives me a 0. That gives me a 0. Add those, that gives me a 0. This gives me another 0. Add those, negative 8. That gives me a 16, and my remainder is 0. So what that means is that this polynomial right here is actually a factor of our original polynomial. So remember, since we started with an x to the 4th, this is going to be the coefficient of x cubed, which is 1. This is the coefficient of x squared. This is the coefficient of x, and that's my constant. So my other factor is 8 x cubed minus 8, which remember that will factor into, this is the difference of cubes. 8 is 2 cubed, so that's going to be an x minus 2 times x squared plus a times b, 8x. Oh, wait, no, that's not x. A times b, so 2x, and then b squared is going to be 4. So, given that one of the factors of my original polynomial is x plus 2, the other two factors are x minus 2 and x squared plus 2x plus 4. Let's take a look at another example. Given the polynomial 2x cubed plus 7x squared minus 53x minus 28, I know that one of the factors is x minus 4. I need to find the other factors. So let's use synthetic division. Since this is already in the form of minus, I will use a positive 4. List my coefficients. I don't think I need any zeros in this case. And bring down the 2 and start multiplying and adding. 4 times 2 is 8. Add, that gives me 15. 4 times 15 is 60. Add, that gives me a 7. 4 times 7 is 28, and that gives me a 0. So these are the coefficients of my solution. Since I started with an x cubed, my answer is going to start with an x squared. So 2x squared plus 15x plus 7, and that will factor into 2x plus 1 and x plus 7. So, given that x minus 4 is one factor of our original polynomial, the other two factors are 2x plus 1 and x plus 7.